Okay, all right. Today's lecture, we're going to start talking about sort of piecewise functions and really how do we take their Laplace transforms. Some important things to remember, in addition to sort of the normal Laplace transforms that you should be somewhat familiar with by now, are the stuff we covered in last lecture. So here, remember we also have an additional piece of notation for this Heaviside function, which sort of starts at C. This here is the Dirac delta, and we sort of call these the sort of T shift or T domain shift properties. Okay, using those, try sort of the following problems. So work on sort of the following warm-ups. Most of these should be pretty straightforward, though do watch out for this guy right here. It's a little bit trickier. All right, let's go over the answers. So this first one's pretty easy. You could really just use the rule on the previous page. Negative 4s over s is going to be the answer there. For this guy here, right, no, we can rewrite this. This is going to be e to the negative 3s times the Laplace transform of a cosine of t. And so we get our answer e to the negative 3s times s over s squared plus 1. This one here, a little bit trickier. Using sort of the same sort of rule, the shift, we get negative 4s times the Laplace transform of t plus 4 e to the t plus 4 minus 4 or the Laplace transform of t plus 4 times e to the t. And so our answer is going to be e to the negative 4s, e to the negative 4s times t times e to the t, which is 1 over s minus 1 squared, plus 4 times the Laplace transform of e to the t. So that's our answer there. Okay, the inverse Laplace transform of 1, that's just the delta function. The inverse Laplace transform of e to the negative 7s over s, the answer there is going to be the Heaviside function beginning at 7. And here we can sort of see that this inside is e to the negative 3s times the Laplace transform of cosine of 5t. So with that, we can see that our answer is going to be Heaviside function times cosine of 5t minus 3. All right. So getting into today's topic, we're talking about piecewise functions. And so remember that this is just sort of, functions, f of t, and they have sort of a different rule depending on where you are. So, might take on the value negative 1 if t is less than or equal to 1. We might be equal to, sine of 4t if, say, t is in between 1 and 15. And then, we could have e to the 7t for t greater than 15. So when we compute the Laplace transform for these guys, what we're going to want to do is rewrite them in terms of Heaviside functions. So to get an idea of how we might do that, let's actually do the opposite. Let's write down a sum of Heaviside functions in terms of a piecewise function. So recall what this Heaviside function is. So it's I use the shifted Heaviside function ut minus c, or uct. This is 0 if t is less than c, and it's 1 if t is greater than or equal to c. So to sort of start this, it's good to note where sort of our changes are. So we're going to have different definitions. So I'll say this is f of t. So we're going to have one definition if t is less than -1. We're then going to have one definition if we're in between -1 and 1. Another one if we're in between 1 and 4. And finally, if t is greater than or equal to 4. And to sort of see what happens in the different scenarios, let's just sort of go through. Let's just assume, okay, t is less than or equal to -1. So if I plug in such a t, right, I'm going to have f of t equals u of t plus 1. Actually, I'll just rewrite the whole thing just to make it really clear where these things are coming from. So u of t plus 1 plus t u of t minus 1 plus sine of t minus t u of t minus 4. Okay, so if t is less than or equal to -1, we're going to have 0 plus t times 0 plus sine of t minus t, again times 0. So our answer is just going to be 0. So if we're less than 1, our function is going to be the 0 function. If we're in between -1 and 1, then, well, this first guy is now going to be equal to 1, but the rest aren't really going to be that different. Our next case is if we're greater than 1 but less than 4. So now that guy is going to be 1, but this last term is still going to be 0. And so our function is going to be equal to t plus 1. And lastly, if t is greater than or equal to 4. And if we do 1 plus t plus sine of t minus t, we end up with sine of t plus 1. All right. So for our next sort of example problem, we're going to write this as a sum of Heaviside functions, or as a linear combination of Heaviside functions. So the first thing to note here is sort of what happens always, what term is sort of always present. And we can see that, and what I mean by always is, for t as low as you can go. And we can see that, if t is less than 5, so as we go to negative infinity, we just take on the value 4. So what that means is there's going to be sort of, as a baseline without any Heaviside function attached to it, there's going to be a 4. Okay. So continuing with that, we can see that we have a jump at 5 and a jump at 7. So that means we're going to have some function times a Heaviside function starting at 5 and some other function with a Heaviside function starting at 7. So now we can just sort of go through and find what happens if t is in between 5 and 7. So we know what f of t has to equal here. It has to be 4 plus t. If we're in between 5 and 7, we're greater than 5. So this first Heaviside function is going to be equal to 1. But we're still less than 7, so this is still going to be a 0. And so what we get is 4 plus t equals 4 plus some function which I called f1 of t. I can see then that f1 of t is just the function t. The only other case we have to consider is t greater than or equal to 7. And here we're going to have 4 plus t plus e to the t is equal to 4 plus 1 times f1, which we now know is t, plus 1 times f2 of t. And here I can just see that e to the t is equal to f2 of t. And so now I can rewrite my function. F of t is equal to 4 plus t times u5 of t plus e to the t u7 of t. Okay. So for this next one, we're going to be given a piecewise function, 1 if t is less than 4, and t squared if t is greater than or equal to 4. And we're going to compute the Laplace transform of f of t. So, first, the way we do this is write f of t as a combination of Heaviside functions. So again, starting off, we're going to have sort of something that's always there is going to be this 1, just because that's how we start for our lowest values of t. Then we have just one breakpoint at 4. And now we see what happens. If t is less than 4, it should be clear what's going to happen. We'll just get 1 like we want. But if t is greater than or equal to 4, then we need to get t squared. And so if we just go ahead and solve for f of 1, we get it's equal to t squared minus 1. And so what we can conclude is that f of t is 1 plus Heaviside function u4 of t times t squared minus 1. Okay. Next, our second and sort of final step, just compute the Laplace transform using, of course, the fact that we could have rewritten it as the sum of Heaviside. Okay, so for this first part, right, we can sort of split it up. Laplace transform of 1 plus the Laplace transform of u4 t times t squared minus 1. We know this is just going to be 1 over s plus e to the negative 4s times the Laplace transform of t plus 4 squared minus 1. We need to now expand this. T squared plus 8t plus 16 minus 1, 15. And now we can get our answer. 1 over s plus e to the negative 4s times 2 over s cubed plus 8 over s squared plus 15 over s. All right. Do one more example just to try to illustrate the general pattern, and I'll say a little bit about that pattern. So we'll consider the piecewise function where from, if we're less than pi, we're going to be equal to sine of t. If we are in between pi and 4 pi, then we're going to be equal to sine of 3t. And if we are greater than 4 pi, then we're going to be equal to cosine of t minus 1. Okay. Oh, and I didn't say what we're doing. We're computing the Laplace transform of this. So we know we're going to start off with sine of t not attached to any heaviside. And then we're going to have f1 of t, and that's going to sort of be attached to a heaviside function at pi, plus f2 of t, heaviside function of 4 pi. Okay, so t is equal, if t is in between pi and 4 pi, then we have that sine of 3t equals sine of t plus f of 1 times 1 plus f of 2 times 0. And so we can go ahead and see, just move that sign to the other side. That f of 1 of t is equal to sine of 3t minus sine of t. Last case, if we're just greater than 4 pi, then we're equal to cosine of t minus 1. So those two will cancel. We move that over to the other side and we get cosine of t minus 1 minus sine of 3t equals f2 of t. Okay, so to sum up, f of t is equal to sine of t plus u pi t times sine of 3t minus sine of t plus u 4 pi t cosine of t minus 1 minus sine of 3t. We're now computing the Laplace transform. So for this first term, right, that's just going to be 1 over s squared plus 1. This second term, we have e to the negative pi s times the Laplace transform of sine of 3t plus, oops, I flipped it, 3t plus 3 pi minus sine of t plus pi. And then finally plus e to the negative 4 pi s times the Laplace transform of cosine of t plus 4 pi minus 1 minus sine of 3t plus 12 pi. Okay, so there's a couple things to note here. So if I have sine of anything and I add a pi, if you think about what happens on the unit circle, I just get the negative. The same thing happens for cosine. And if I add 2, if I look at this rule, I get the negative of the negative, so I just end up where I started with. And so, you know, again, if I add 3 pi, well, I just get the negative, and so on. So if I add a odd multiple of pi, I get the negative. And if I add an even multiple, I get what I started with for both sine and cosine. So here, this is going to be the Laplace transform of negative sine of 3t, and then minus negative sine of t. Here I'm adding even multiples. So I just get back what I started with. And so if I now go ahead, I can sort of simplify and get my final answer. 1 over s squared plus 1 plus e to the negative pi s times negative 3 over s squared plus 9 plus 1 over s squared plus 1 plus e to the negative 4 pi s times s over s squared plus 1 minus 1 over s minus 3 over s squared plus 9. And that is my final answer. Okay, so that one was pretty complicated. Last thing I will just sort of say, note we sort of, maybe you have noticed sort of a pattern here. So if we look at what f we started with and what we got in terms of a linear combination of Heaviside functions. And we'll look sort of back up here as well. So here was our f, and here was our linear combination of Heaviside functions. So just sort of the general pattern I want to note. So if we have G0, G1, A, if we're in between A and B, G2, if we're between B and C, and I think that's enough to sort of see the general pattern. Then essentially how you get, what we're multiplying by that Heaviside function for, let's say, B, is it's whatever we want it to be minus just the last, what it just was, essentially. And of course, there's nothing special about, there being 4 different things here. This pattern would continue onward. And just to sort of see what happens, so it should be clear, right, if t is less than a, like the formula should hold, because that, and that are all going to be 0, so we're just going to get g of 0. Okay, well, what if we're in between A and B? Well, right, we should get g of 0 plus 1, g of 1 minus g of 0. And then plus every other term is going to be 0. So the plus g0 cancels with a minus, and we just get g1. If we're in between B and C, then sort of note what happens. So we have g of 0 plus 1 times g of 1 minus g of 0 plus 1 g of 2 minus g of 1. And then plus 0 g of 3 minus g of 2. Now it might sort of seem maybe at first that maybe we needed to add like a minus g0 term, but because we already sort of got this first part right, we already have the minus g0 term right here. So, right, this is going to cancel with this, and then this is going to cancel with this. So we only have to cancel out sort of what it just was, and we'll get g2 of t. Yeah, so that's a formula you could use, pretty useful for a lot of things. All right, I'm going to end it there.